Hey everyone! So when you first learned to do systems of linear equations, you probably learned how to, eliminate one variable, multiply by something to eliminate one of the variables, and then add your equations together to solve for one variable, and then substitute back in. And that works. But we're going to look at a different way to go about solving a system of equations. And here we have something, pretty fairly simple. Two equations, two unknowns. And what we can do is just take our coefficients on our variables. So we have, 8x1 plus 6x2. So we just take the coefficients, the 8 and the 6, on our first equation, and then the coefficients down here, a 5 and a 4, and we write it as a matrix. Now, we take this matrix and we multiply it by then whatever the variables we have. So x1 and x2. Okay, so now we have this 2 by 2 matrix. There's 2 rows, 2 columns, and a 2 by 1 matrix, 2 rows, 1 column. And if we multiply these matrices together, what we're going to get is a 2 by 1 matrix, where the first entry is just going to be our first equation. It's going to be 8 times x1. So 8x1, then plus 6 times x2. So 8x1 plus 6x2. And our second entry is just going to be the second row and by the first column. So 5x1 plus 4x2. That's exactly the equations we have. And what does this equal? It equals the 2 by 1 vector to -1. Okay? So we can say that if we call this matrix A, let's say, we can say that A times the variables, and we just call it, let's say this is the x vector, which is, in this case, we have two unknowns. So the x vector is x1, x2. Well, that's going to equal whatever the answer is. And that's going to, let's say we call this B vector. Okay? AX equals B. AX equals B. Well, how would we solve for our x vector? Well, if this is A, we say we could divide by A. Let's say we had, 5x equals 10. Okay, how would we solve 5x equals 10? We divide by 5, right? But you could also multiply by the inverse, by the multiplicative inverse of 5, which is 1/5, right? Then what happens? The multiplicative inverse of 1/5, well, 1/5 times 5 is going to be 1, and 1 times x is x, and then 1/5 times 5 is 2. So x equals 2. Well, in this case, A is now a matrix. So we can't divide by a matrix. But if A has an inverse, we can multiply by the inverse of A, and then A times A inverse is just the identity matrix, and then the identity matrix times x is just going to be x. So if we do the same thing to both sides, we find that x vector, which is what we're trying to find, our x1, x2, is just equal to A inverse times B. So we multiply both sides by A inverse, we're just left with x equals A inverse times B. Okay, well, how do we find A inverse? Well, we have a 2 by 2 matrix, and finding the inverse of a 2 by 2 matrix is pretty simple. This method only works for 2 by 2s. If you have a 3 by 3 or anything greater than that, I wouldn't say it's not. You can still find the inverse, but it's a different way to go about it, and this won't work. Only works for a 2 by 2. But to find the inverse of a 2 by 2, all we do is take 1 over the determinant of A. Well, this is our matrix A. What's the determinant? The determinant is just the product of this diagonal minus the product of this diagonal. So 8 times 4, 32, minus 6 times 5. So 32 minus 30. So the determinant of this matrix is 2. So to find the inverse of the matrix, it's 1 over the determinant. So 1 over 2, but then multiplied by what you basically do is just swap these two entries. So the 8 and the 4 swap. So the 4 comes here, and the 8 goes down here. And then we just change the signs on the other two entries. So we have a 6 and a 5, so they become a minus 6 and a minus 5. Okay? So then, well, what do we get? This is a scalar times a matrix. So this is just equal to the scalar times every entry. So 1/2 times 4 is 2. 1/2 times minus 6 is minus 3. Half times minus 5, that's minus 5 halves. And then 1/2 of 8 is 4. Okay, so there's our matrix. We just found A inverse. Now we're trying to find our x1, x2, which is our x vector, which is equal to A inverse times B. We just found A inverse, and our B is just whatever our equations are equal to, which is the 2, 1 vector. So 2, or 2 minus 1. So 2 minus 1. All right, so here we have it again. This is a 2 by 2 matrix. This is a 2 by 1 matrix. So what we get out of this is a 2 by 1 matrix. So we're going to have some 2 by 1 matrix, okay? So what's the first entry? That's the first row, first column. So it's the first row of A multiplied by the first column of B. So it's 2 times 2, so it's 4, and then plus 4 plus minus 3 times minus 1, well, that's plus 3, so 4 plus 3, so that's 7. Okay, and then what is our second entry? Well, that's the second row, first column. So it's second row times the first column, so minus 5 halves times 2, well, that's minus 5. And then, so second row, first column, minus 5 halves times 2 is minus 5, and then 4 times minus 1 is minus 4, so plus a minus 4, which is minus 4, so minus 5 minus 4 minus 9. So we just found that x1, right, x1 is equal to 7, and x2 is equal to minus 9. And if you go ahead and plug these in, x1 equals 7, x2 is minus 9, back in to these equations, either one, they're both going to come out equal. So there you have it. Another pretty, systematic and pretty simple way to go about solving a system of linear equations. All right. See you. Be sure to subscribe and give me a like, and I'll see you guys soon. Bye-bye.